Fusion 103 prediction. In this part of the tutorial, we will be kind of shooting little balls from our cubicle players. And the interesting part of this tutorial is that these balls, which are spawned by the players, are automatically synced over the network with a quite sophisticated method, which is very well explained in this section of the tutorial. In short, the movement of the balls is simulated on each client, but they are resynced by fixed network updates which are coming from the server. So the server has the authority on where these balls are actually moving. But since the server over the network is always lagging a bit behind the client's position, the client then will reapply all the simulated movements which came after the tick, so that the ball should never slip behind time. So the server state should never slip behind. And this will happen completely automatically using the Fusion Network Transform component. Without further ado, let's dig into this part of the tutorial. In this lesson, our game will become much more gamey by adding this possibility to kind of shoot these balls. So we go ahead and create our ball prefab here. Prefab and reset the position of this one, the transform, reset. And we need to add the network object to give it a network identity. This is always necessary, network object, like so. And then we add the network transform, which will do this magic by keeping this synced with the server, including the prediction of where this network object will be. And what's missing here still is our actual transform, so the interpolation target. So we now add a sphere, which makes kind of sense if we're creating a ball, and call it the ball sphere. And ball sphere here, like so. Make it a bit smaller, like 0.2, 0.2, 0.2, like though. And now we are dragging this ball sphere into the interpolation target, and this looks nice. But the sphere collider, which is in here, must move from the, let's go a bit closer here, sorry, too close. So must go to the prefab here. So we remove the sphere collider, remove, and add it back and here, sphere collider. And this one is a bit too big, as you can see, so we scale it down to 0.1, and then it actually fits exactly where it should be. On the prefab, we also need a script, which we will add in a moment. So we're adding a ball script. Yep, like so. And with this set, we can go ahead and create an actual prefab from this one, like so, and save the scene and remove this one. And save once more, and then we can go ahead and start the code editor. Okay, what does a ball do? A ball rolls on its own. We have no friction, I think, here. So the first thing we have to do, we have to change this to network behavior, because this is a network controlled object. So network behavior, and this should come from Fusion. Exactly. We can remove again the start and the update method and replace it with our already known and trusted override void fixed update network component, which takes over the function of the regular mono behavior update one. And in every update, we just change our position by applying the forward direction multiplied by 5, so fixed speed forward of the transform. So we will changing the transform position, and we will just use the runner.delta time, which is the replacement of the timer.delta time in the networked instance. So this basically moves the ball once it's spawned every fixed tick by 5 units in the forward direction. And this is actually done on the client, so it's predicted on the client. And since if you're doing this like this, the ball would never despawn and it would go up into infinity. We need a way to despawn it after some time. So the way the tutorial suggests is to use a TickTimer, which is a fusion component, which is also synchronized above, over the network. So we do a networked, we flag it with a networked attribute, and we create a private TickTimer life like this, and use a property set like so. And this TickTimer actually has an end of life, so you can set it to running like 5 seconds, 10 seconds, or whatever, and then it can be queried if this TickTimer is expired, and it's only updated, so you cannot actually query the rest the time, but once it's expired, then the flag is set and we can despawn our ball afterwards. So obviously we also need to initialize this one. So we have an init function, and in the init function we will set this tick timer life equals tick timer dot create from seconds on the runner, and we need 5-second despawn time. So this will now tick exactly 5 seconds, and we can add to our fix update that in case the thing is expired, if life.expired on the runner, then we despawn. So runner.despawn ourselves. So this is object. This is the Fusion network object. So this is self-destruction, and if not, then we can move our position. So like so. This is actually now the code for the ball. As soon as it expires, then this one will despawn, and afterwards it's gone. So no more fixed update network ticks. So it should not be called twice. So it only despawns once. Okay, now it despawns. Now we also need a method to spawn the ball, and this obviously will be on the player. And we will do this as soon as the player hits a key, or in our case, a mouse button. In order to have the mouse button propagated to the server to be processed, we extend our input data structure here, and we're adding a constant. So to have a mouse button 1 public const byte mouse button 1 equals 1 byte 0x1, like so. Then we add a public byte buttons, and with this we have this set. So if the buttons are clicked, we can assign this to the buttons field here, and it will be transferred over the network and processed in our basic spawner script. So the basic spawner script here has this input processing with the keyboard input already. And what we will need to do is we now need to add the mouse button processing. So below here. So we are saying if mouse, no, sorry, mouse, sorry. Okay, so it's obviously not in the input, so I need to read the script carefully. So obviously the mouse button we will not get in the, we will need to have the real input method to capture the position of the mouse buttons. So we will set a private boolean if the mouse button 0 is clicked. So mouse button 0, 0, and then we have to re-add the deleted update method. And here we can actually now say the mouse button status, mouse button 0 status equals mouse button 0 status, or input dot get mouse button 0. So either it was already pressed, or so once it's pressed, it's pressed. And this means that even if the user releases the mouse button later, or holds it pressed for a couple of times, it will be the processing will be only done once, because we will reset the flag now here. So if the mouse button 0 is pressed, then we will add the flag we just defined. So it's a byte flag, so we can have multiple network input data dot. We can have multiple mouse buttons within one single byte, so up to 8, obviously. And afterwards, after this processing is done, sorry, that's not and, this is or equals. So it's in case we will add multiple mouse buttons, it's just a logical OR here. Not a logical, it's a bitwise OR. And after setting this, we will reset this to false. So we processed it, and then we set the input data. All right, now, if the mouse button was clicked during the update, then the flag will be set, and this one will be queried at any point later from the network. And if the mouse button was pressed before this on input was called, then it will be set on the input structure and propagated over the network. Right. So this was the input processing, and now we need to have the actual spawning implemented, which is in the player script. So in the player script, we have our fixed network update method here. And what we will now do is we will need to add the spawning of the player here. So first of all, we obviously need to have the reference to the prefab we want to spawn. So we add a serialize field here, serialize field, call it private ball prefab, no, a ball, I called it ball, ball, yeah, okay, prefab ball, this is this one, and then we also need to have a vector 3 forward direction, which I guess I didn't look at the code, I'm doing this on the fly here, which I guess will be needed for the calculation of where the character is looking at the moment, and we want to shoot the ball in this direction. So we have a vector 3 forward, which is not propagated. And then we need to add to our input loop here, after we are moving the player, we also want to move, spawn a new ball in case the button is pressed. So if our data dot buttons are bitwise and network input data dot mouse button, if this one is pressed, if this is not 0, then we need to spawn our prefab ball, and we need, sorry, this is like so. So we want to spawn this in transform dot position plus forward. So where does this forward vector comes from? Okay. Okay, I forgot to add something, so I would just calculate the add here. This is happening before this. So we are always calculating the forward vector. So if data.direction.square magnitude equal bigger than null. So if we have a direction, then forward equals data.direction. So the direction we are looking in. And now we're adding this forward vector, and we also want to have the looking vector, the rotation, so that the forward vector of the ball looks into the same direction. So we are doing a look rotation, and we are looking in the direction of the forward vector, and this will then set the forward vector of the ball to this one. And we want to give this one object input authority. And this is basically the first thing. I still have a problem here if, okay, this cannot be calculated like this. We need to have this one first, right? Okay, and then if I read this a bit further down, we need to despawn this, and if I remember correctly, there's still something missing. Yes. Here again, this if you keep the mouse button pressed now, this would rapidly spawn a lot of balls. And since we want to have a kind of a debouncing, we also will be using the TickTimer we just used a couple of minutes ago. So also here we add a networked like so, TickTimer. Call this one delay. Something wrong one here. Okay, and then we can just wrap this in our expired thing. So if delay dot expired or not running. Okay, okay. So hopefully delay expired or not running, but this is null, right? Okay, I'm not sure. So like so. If it's expired or not running, then we can trigger this. And obviously, now we want to have, after the first click, we want to have a delay. So we just add, as the first line here, once this is clicked here, we can add a delay equals tick timer, create from seconds, runner, and they suggest half a second. So now this ticks for half a second, and during this time the mouse buttons are just ignored and are reset afterwards. And run a spawn, transform, this looks good. And then there is a remark in the tutorial that there is still a tiny thing missing, which is that the ball component, if we spawn it like this, needs to be initialized. So I didn't investigate further why this is necessary, but I can just add the necessary code here. And this is, how is this called here? This is the onBeforeSpawn method. So before it's spawned, call this one on the ball. This is our init, because it's init is not called automatically. And in this init, we set the despawn timer. So this makes sense. So we get the component ball from this one, and then we can call our init function here, which will then set this one here. So basic spawner saved, everything saved, and this should be it if I see this correctly. Now, if I didn't mistype something, this should already be the whole lesson 103 in one go. Let's test it. Okay, let's test. One last thing I just forgot is we also have to add this ball prefab to our player prefab so that the player knows what to spawn in case somebody presses the mouse. So I add this here. Then we save the whole thing. Then we can go ahead and just build. And once we're done, we should be able to shoot at each other. And let's see. So start one instance. Start the second instance. We host. We wait a bit. We join. And for whatever reason, this again takes some time. So now we go here, and I can move, and I can shoot. Hey, hey! Look at this. And since we have rigid bodies, we can shoot each other. And then I'm gone. Nice, nice. So, I'm still alive, but I'm somewhere very deep below. So I despawn and add another one right here. So, bam, we join. And now let's shoot this Betty here. Ooh, what's this? So if you shoot before you move, then obviously this seems like, oh, it's difficult to hit this one. Bam. No. Come on. I will get you. No, still not. Now. Ha. No. Bam. Ah. Ah. Still.